Hi, this is Dr. Liu, and in this video we'll discuss how to solve systems of two equations or even systems of three equations. In the previous video I discussed how to solve a quadratic equation which has only one unknown x but in different powers, such as x squared, x, or a constant with no x. And in this video, the system of two equations, it involves two separate unknowns, and they have to be solved simultaneously. So now let me give you an example of such a thing. I have on my notes 2x plus y equals 8, and x minus 3y equals minus 3. So the question is, x equals what, y equals what? Right, so we're looking for two values, and they each are the solution of one unknown. Okay, so how do I solve this problem? There might be different ways to solve problems like this, but I like to teach a typical method that is not the quickest, not the slowest, but the sure thing that you can use to solve problems. So first I numbered the equations because I can always refer to the equation by their numbers. So we recognize we have two equations, two unknowns, so that is a solvable situation unless the two equations are somehow conflicting with each other, such as x plus y equals 5, x plus x plus y equals 3, and then is it equal to 5 or is it equal to 3, right? So alright, let's get started. And what I want to talk about, the way to solve it is to do substitution. So to solve by substitution. Okay, so let's imagine that we only have one equation and that equation has one unknown. I'm pretty sure you can solve that, right? So our goal is to reduce two equations, two unknowns, to one equation and one unknown. The way is to express one of the unknowns in terms of the other, so you can eliminate it using substitution. So it's your pick which value you want to be substituted away. So let me give you an example. I'll start with equation 1, and equation 1 I will just do equation 1 subtract 2x's on both sides. So what does that look like? 2x plus y minus 2x, 8 minus 2x, right? So these subtract away, so I get y equals 8 minus 2x. So although this is not a solution for y, a solution would be y equals a number, right? So this is just y equals an expression. This is still useful because anywhere you see y, you can get rid of it and you turn that into x in the values, so y is gone, and you get your objective. You will be solving a single equation with a single unknown. So this one we'll still call it 1 because it came from 1. And if we look at equation 2, it has y. So if we substitute that y with this expression, y is gone and replaced by x and numbers, so we get our wish. So we can say that equation 1 plugs into equation 2. Okay, so how does that look like? X minus 3, now y gets replaced by this. 8 minus 2x equals minus 3. And I'll distribute 3, so x minus 3 times 8, and the minus is plus 3 times 2x is equal to minus 3. So let's keep going to the right because my electronic paper is wider than it is long, right? So let's keep going to the right. We have x minus 24 plus 6x equals minus 3. So now what I can do with this equation is I can add 24 on both sides, so the left side will be only x's and the right side will be only numbers. So let's do that. I'll say that equation 1 plus 24 both sides. So now I have x minus 24 plus 6x plus 24. I know this might seem a little slow, but it helps everyone to stay on track. So the 24 is subtracted away. 6x's, I have 7x's, and the 24 minus 3 is 21. So x is equal to 21 over 7, and it is 3. Well, I made this up so that I started by assuming values x and y, and then I made these equations just to make them easier. Okay, that doesn't look like, that almost look like prime. Okay, so x is equal to 3. So where do we go now? Now we have one of the two solutions, and this should go into where I made my substitution. This equation right here, where it says y is in terms of x. So if I put x in there, I'll get y in numbers. So I can do y. Let's say that this is still a let's see. Okay, I think I should say equation 2. This is equation 2. So this still is equation 2. So equation 2 back into this equation 1 in this form. So you have y equals 8 minus 2 times 3. So 8 minus 6, y is equal to 2. So now my solution, x is 3, y is 2. So that's solved. Right, so basically what we did was I just picked one equation. I picked one unknown. What I want to keep, I want to keep y on one side so I can express y in terms of the other unknowns. That's why I subtracted the 2x away. I could have picked x, but then I have to divide by 2 to get x equals something y, right? So this is basically whichever equation you pick is your own choice. I typically pick one that has just something, this unknown in a single, right? So we don't have to divide a factor out. I could also have picked this equation and just add 3y to both sides. That gets me the same effect. I get x equals something. Alright, let's move on to a second example where we have 5x plus 2y equals 5 minus 2x plus 3y equals 17. And again, I started with assuming x and y's values, and then I made up some equations. Okay, so let's call them equation 1 and 2 again. Alright, so in here I don't really see either equation as more advantageous than the other. I have to divide by 2 in either case to try to extract y or x. So I may as well just start with equation 1. Okay, so I'll take equation 1 and I'll subtract, how about I subtract 2y, so that I'll have 5x's on this side, right? 2y subtracted away, I'll have 5 minus 2y. And then I can divide both sides by 5. So I get x equals 1 minus 2/5 y. Alright, not the best, but still it should work. So this still is called equation 1. And then I can use equation 1 to plug it into equation 2. So I'll do 1 plug into 2. My equation 2 will no longer have x. So minus 2. This whole thing is x 1 minus 2/5 y plus 3y equals 17. Alright, so let's distribute the minus 2 inside of the parentheses. Again, minus 2, minus minus plus, 2 is a 4, plus 4/5 y plus 3y equals 17. Okay, so now we can combine the y's. So we'll have 3, so over 5 is going to be 15/5. 15 and 4 is 19/5. Y equals 17. And if I add 2, so this is my equation 2. Add a 2 on both sides. This 2 is gone. Minus 2 is gone. So 19 over 5 y equals 17 plus 2. Phew, now 19 comes out. I was a bit worried that I may have made a mistake. Okay, so we have 19. Alright, so we can divide 19 out. 1/5 y equals 1, and multiply the 5, so y is equal to 5. That still is equation 2. Just like this one was still called equation 2. Alright, so now we have this. We can go back to this equation where we have x in terms of y. So this equation is equation 1, 2, plug into equation 1. And we have x equals 1 minus 2/5 times 5. Okay, that's not hard. And that divide, so 1 minus 2 is negative 1. So we have solution x is minus 1, y is 5. Okay, so what if we have say more equations, say a system of 3 equations, 3 unknowns? Can we still solve with the same method? The answer is yes. We still use substitution. So we still take one equation and massage it into one unknown is equal to the other 2 unknowns and constant, and plug that equation into the other 2 equations. So that first unknown is gone, and then you end up with a system of 2 equations and 2 unknowns. And starting from there, you redo this. Take one equation and express one unknown in terms of the other unknown and plug into the other equation. Now you have one equation, one unknown. So let's do this with this example. So 3x minus y plus 2z equals 4. X plus 2y minus z equals 5. And minus x plus y plus 3z equals 8. Okay, so we're solving for x, y, and z. Equation 1, 2, 3. And as you see, I don't have a lot of space. I can certainly scroll down indefinitely, but that's not my goal. My goal is to tell you how to do this. You can do it on your own. So first I can just pick one equation at random, so I'll just pick this equation here. And since y is in the single, all I need to do is add y on both sides, right? So this side is 3x plus 2z, the other side is 4 plus y. And then I can subtract 4 on both sides and also switch the left and right side later. So 3x plus 2z minus 4 equals y. So now I have this y, right? Y is equal to this, and it still is equation 1. I can take equation 1 and substitute it into equation 2 and 3 to remove y. So 1 into 2. X plus twice this whole thing, 3x plus 2z minus 4 minus z equals 5. That still is equation 2. Now 1 into equation 3 is minus x plus this whole thing is y, 3x plus 2z minus 4. In the z term, this is plus 3z. Plus 3z equals 8. That's equation 3. Okay, so we can sort out the terms. Let's sort out the terms. And I have 2 times 3, right? 6x's, 7x's, so 7x. And here's 2 by 2 is a 4. 4 minus 1 is 3. So plus 3z. And constant wise, I have 2, 4, that's minus 8. Right, minus 8, if I add 8 on both sides, there's no constant on this side. And the 8 appears here, plus a 5, 13. And let's do the same thing here. Combine the terms. 3 and minus 1 is 2. 2x's. And the 2 and the 3 is a 5. 5z. and we have minus 4, so we add 4 on both sides. Now we have 4 and 8, 12. Alright, so now we have a new system of two equations and two unknowns, and then if you solve it the same exact method as we did, you'll be able to get, so let's do dot dot dot, you solved it, you got let's say you somehow eliminated x, you got z. So what is z supposed to be? Z is equal to let's see, let's actually have the details. Let's have the details. So from equation 3, what we can do is we can turn this into x equals 6 minus 5 over 2z. Well, you do the math, subtract that term on both sides, divide by 2. Alright, so you have this, which is still equation 3. So 3 plugged into 2, you eliminate x, you get z. So your solution, you get z equals 2. Okay, so this is that equation 2 that you eventually solved after all the substitutions were done. So where do you go now? You go back to this substitution, so that with z plugged in, you can get x. X is actually 6 minus 5 over 2 times 2 is 1. So you get x equals 1. So now with both of these, you can return to this first substitution where you got rid of y. So plug in x and z now, and that gets you y equals 3. So this should be done with a bit more linear pattern. That means writing downward, writing lines down and down until you're done. And this I'm just I don't want to scroll, so that I'm showing you the basically just the outlines how to solve the problem. But the idea is the same. You have however many equations, you take one of them, you turn it into an expression of one unknown in terms of the other, and you plug this expression into the rest of the equations so that you get rid of this unknown. Now you are one less unknown, right, after you sort out the terms, and then you repeat that process. Pick an unknown from with one equation, one unknown, express that unknown in terms of the other unknown, and plug it into the other equation, and now you reduce it into a single equation, single unknown. You can solve that, and once you solve it, go back to that previous substitution where you got rid of the x, and you can find the x now that you know the z. And then you take both now known quantities and go back to one previous substitution. Now you get this. And if you had more previous substitutions, you just keep going back. Thanks.